Today we're visiting an area between Erin Point and Punta Blanca. This Kugler surface geology map indicates that the area is almost completely covered by thick mudflows. This 50,000 scale Kugler surface geology map shows the distribution of the mudflows, upper and lower cruise formation. The lower cruise is mapped as clay pebble beds. The main problem with its location is that we would expect these outcrops to be located along the crest of the southern anticline. Its position, therefore, is anomalous. They probably represent disturbed sediments with boulders within mudflow. The pink dots are the outcrop localities, and we can clearly see that some of these localities are significantly inland of the 1959 coastline, suggesting significant coastal erosion. In this structural cross-section, using wells and surface geology, it has been interpreted that the mud is rising upwards along a reverse fault to the surface. The lower cruise and lengua formations were proposed as a source of the mud. However, common chert and Herrera class suggest a Cepero source for the mud. This topographic map shows the location of some of the outcrops visited. This montage shows the location of a mudflow on the 1959 Kugler surface geology map and 2019 Google Earth image. This mudflow corresponds to the location of a heavily vegetated slope failure. There are no obvious active vents. To follow, we will see an animation of how this mudflow / slump has changed between 2001 and 2019. At the head of the slump or the legacy mudflow, there's an area of disturbed ground. The area is being cultivated and no active vents are visible. This area will be investigated at another time. In this panorama, we see extensive slumping of legacy mudflows due to wave erosion. In this drone photo of the shoreline between Erin Point and Punta Blanca, the accurate pile of boulders represent the furthest point of advance of either slumps or mud flows. Either there has been significantly coastal retreat or slope failure and mudflow activity has been negligible, allowing for the waves to erode away the muddy sediments. We are approaching Punta Blanca and we're still seeing old mudflow being exposed here on the coast. Typically, these piles of boulders represent the point of advance of old landslides or old mud flows. So we're now at Punta Blanca and we see a huge scree of boulders in front of the headland here. In the distance we can see the red porcelainite cliffs closer to Chatham. Looking south, we see the Venezuelan coastline at Punta Pescador, with a number of ships involved in transshipping cargo from the interior of Venezuela. In this block of parallel bedded Herrera sandstone, there are abundant lignite fragments. In this coarse to medium grain sandstone, there is abundant lignite. The yellow staining is the result of the oxidation of these lignites. This sulfur content reflects the depositional environment, which is brackish water to lower delta plain. So we are at a well-bedded part of the outcrop. Well, rather an outcrop. It's a piece of well-bedded sandstone with some lignites in it floating within the mud flow. In this photomicrograph, we see a close-up of the lignite band from the sandstone. It's a homogeneous mass, small oval bodies that form a linear pattern. In this photomicrograph of a sandstone that resembles Herrera, the black fragments resemble chert, giving the sandstone a salt and pepper appearance. The black fragments are very hard and are thus not lignite. The sand is firm to slightly consolidated, fine to medium grained, poorly sorted. It has fair visible porosity. Grains are sub-rounded to subangular. Here we see a bit of bedded rock. As we approach the mudflow here, we see a lineation which probably represents the basal slide plane of a slump. We're seeing a lot of material like this boulder here that appears to be Herrera looking. We're also seeing these boulders here with calcite veins, which typically represents some kind of metamorphic process and do not belong to the cruise formation. So what it suggests is that, especially when we start seeing clasts of chert like these, and we see this interesting concretion of chert surrounded by carbonate type material. Cherts typically are associated with the Naparima Hill Formation and were eroded into the Cepero. Here we see a block of oil impregnated sand within here. So somewhere in this vicinity in the subsurface we have oil bearing reservoirs. So the fact that we're seeing these cherts and the Herrera type sands strongly suggests that the origin of these muds is Supero age material coming up to the surface, and probably not lower cruise as suggested by the 1974 by Higgins and Saunders. So here we are seeing more of these blocks with the calcite or quartz veining, which really don't belong to the cruise formation. Here we see a block of oil-impregnated oil sand that was eroded from the mud flow. In this close-up of oil-impregnated sandstone, it is very hard, very fine-grained, well-sorted, predominantly subangular to subrounded, clear quartz, the other lithic fragments, carbonaceous fragments, very slightly calcareous, liquid not being absorbed readily, which suggests poor permeability. The grains are oil stained and they are abundant clear micas. Here we see a large block of sandstone that has been weathered out of the mud flows. The sand is very fine to fine grained, firm to slightly friable, poorly sorted, predominantly clear to translucent quartz grains. Fine carbonaceous material is distributed throughout this sample. Grains are subrounded to subangular. Within the sandbed are abundant arenocolites. These are common in an Scolithus ichnofacies developed along sandy shores with moderate to relatively high energy conditions, such as a beach foreshore and shore face. In this panoramic drone photo taken from 250 feet of Erin Point, it shows a piece of the uplifted beach at the toe of the slump legacy mud flow. It is clear from the photo that the coastline on the eastern side is being eroded faster than the western side. In this cartoon, we illustrate how a rotational slump and its compressional toe has created the uplifted beach and the scarp at the front of the slump on the current coastline. Fairly large blocks of sandstone coming out of this mud flow. At the top of the rotated slump block, we see the sand and the large boulders confirm the location of the old beach. That has become this mud flow on the Google map. You see, it's a fairly homogeneous mud, large class of sandstone, probably oil bearing. You see that it is yellowish in color, so it means that there is some amount of sulfur-related material within it. So here we have a close-up of the mud. We see there are lots of little pebbles in it, which is typical of mud flow. Here we have a big scree of boulders at the base of this legacy mud flow, and it actually looks like a big landslide on the Google Earth image. Here we have a large class of calcareous type material that is typical of cruise formation. In this weather, the clays collapse very easily. Here we see some more large stones in the old mud flow. And it is obvious that the coast is retreating by wave action. As you can see by the number of trees that have collapsed onto the beach. Here we see an armored mud ball as described by Kugler many years ago. Here we have a large block of material that is typically described as Pereira. This here is a very large block. It's probably about 8 feet by 6 feet in dimensions. We see a lot of sulfurous type material at the top of this route here, and it probably represents an old wave cut platform. Lots of fairly large blocks of sandstone at this point here, and it clearly looks like a big slump. Also, these blocks of sandstone here should represent cruise rocks. You see that in these sandstones there are bands of carbonaceous material parallel together. Here we have what looks like a large chute within the mud. Thanks for watching this video.